All right, well, let's look at this one. This one we're going to have the limit, again, h approaches 0, x plus h plus 3, minus 3, sorry. X plus h minus 3 to the negative 1 power minus x minus 3 to the negative 1 power over h. Well, I bring this one to talk about because it's a little different format than the previous one. However, it's very much like the previous one. Because what does this minus 1 power mean, really? Does that mean flip it over? The minus 1 means flip it over and make it a positive 1. So this is really the limit as h approaches 0 of, and then you still have over h. But then this one will be 1 over x plus h minus 3 to the first power, but the first power is just as is. And then we'll have minus what? X minus 3 to the negative 1 would be 1 over x minus 3, wouldn't it? I mean, I'm not writing it. It becomes positive 1 power, but you don't have to write something to the 1 power because it's kind of understood to be that. See what I'm saying? So that's just another form of writing that complex fraction like we had previous problem. So what do we have to do? One way to do it is go ahead and combine some fractions here. The LCD of the top, wouldn't it be x plus h minus 3 times x minus 3? And so I need to multiply the first one by what? First one by x minus 3 over x minus 3. And then the second one over here, multiply it by x minus h, or x plus h, should say, minus 3. Okay, so we're getting some pretty good algebra stuff here, combining some complex fractions and all that good stuff. Let's see what happens. Usually nice things happen. You haven't already noticed that. All right, so yeah, now I have common denominator of this and this. They're the same. They're just reversed, but they're the same. So I can combine those into one denominator with this common denominator. The top over here, well, the top over here is just x minus 3. The top over here, again, it's minus 1 times all these, so it would be minus x, wouldn't it? Minus h plus 3, because that is a minus 1 times all those. Okay, so this is the limit as h approaches 0. What happens? Well, nice things happen. The x's go out. The minus 3 plus 3 goes out. Hey, again, we're left with, on top over here, just minus h. Then the bottom is x plus h minus 3 times x minus 3. And then it's all over h, but that means times, doesn't it, 1 over h? So h's again, nicely. Cancels out. Can I substitute? Yes, I can. Now I can substitute, h goes to 0, so I'll have minus 1 over x plus 0 minus 3 times x minus 3. Notice the x's are staying in there. It's h that's going to 0. So the x's stay in there. Just the h goes to 0. And so I'll wind up with negative 1 times x minus 3 times x minus 3. Which is a pretty good answer, but how might we go with that? Since they're the same binomials, write it as a binomial squared. It's negative 1 x minus 3 squared. So either this or this, I'm okay with. So this is another one where we didn't get an actual number answer. Sometimes that'll happen. All right, question on anything there? Is that okay? All right, let's talk here a little bit about limits of piecewise defined functions. The ones where the function, the function is defined up in different parts, like f of x equals 2x minus 9 if x is less than 4, and then x squared minus 1 if x kind of goes the other way, greater than or equal to 4. All right. Okay. The question on some of these anyway then will be what is happening at basically at where it breaks down. In this case, x is 4 is where we have the break of this piecewise defined function. So that's what we're going to examine here. First of all, number one, what is f of 4? Just answer that one. Well, f of 4, wouldn't f of 4 be this one? Because when x equals 4, I'm going with this one. With me? 4 squared minus 1. 15. Okay. But really the idea we're looking at is limits, but the actual function value is 4. The real question here that I want to get to is the limit as x approaches 4 of f of x. Does it exist? Is it 15? Does it exist? Well, this is getting back to kind of the definition of limit. When we're talking about limit, we are really talking about left and right. What happens as you come in from the left and what happens when you come from the right. And so that, on these piecewise, is what you have to look at. You have to look at the limit from the left and from the right. In other words, the limit as x approaches 3 from the left, which is 3 with the minus is how we denote it. And we need to look at the limit as x approaches 3 from the right, because for this limit to exist, what has to be true? You have to have a limit from the left, you have to have a limit from the right, but what else must be true? They have to be the same, right? So that's the issue that we run into on these piecewise. Are these limits the same? Well, what's the limit from the left? 3. Where did I get 3? This is supposed to be 4. I don't know where I got 3. 3 on the mind there. We're approaching 4 from the left and 4 from the right. Change that over. Okay. All right, so 4 from the left. If we're approaching 4 from the left, which one of these parts am I talking? From the left, that's the less than side of 4. Talk about on the number line here. Here's 4. So if I'm approaching 4 from the left, I'm approaching from the less than side of 4. So which one of these do I use? I would use the 2x minus 9. So this limit as I approach x 4 from the left is the limit as x approaches 4 from the left of 2x minus 9, which is, I can substitute there because there's no problem substituting there. So it's 2 times 4 minus 9, that's negative 1. 8 minus 9. All right, the limit as x approaches 4 from the right, though, well, if I approach 4 from the right, that's coming from the greater than side of 4, so that is the x squared minus 1, isn't it? So I'm looking at the limit as x approaches 4 of x squared minus 1, which is, substitute in 4 squared minus 1, 16 minus 1, that's back to 15 there. Okay? So back to the original question then. Does the limit as x approaches 4 exist? It does not. Okay? Of this f of x, the limit as x approaches 4 does not exist. D and E. Because, why? The limit from the left does not equal the limit from the right. And that's, I did start grading on some of your homework there, and yeah, when it says explain, if something exists or does not exist, and it asks you to explain, then what it's asking or looking for, the best way to explain it is the limit from the left does not equal the limit from the right. So if you want to just shorten it to this, this would be sufficient. Okay? All right, let me mention one more real quick here. Let's say f of x equals x plus 1 if x is less than or equal to negative 2. So x over 2, negative 2 is less than x is less than 4, and 6 minus x squared if x is greater than or equal to 4. So this one has two, if you will, two breaks in it as far as the x goes. So on this one, let's look at the limit as x approaches negative 2. We could do the same thing with 4 again, but let's look at x approaches negative 2. To do the limit as x approaches negative 2, if it's defined up this way, yeah, you got to look at it both ways. What is the limit as x approaches negative 2 from the left? And what's the limit as x approaches negative 2 from the right? See what both of those are. The limit as x approaches negative 2 from the left. Oh, the other thing is, what does this mean? I don't know that we've had that one yet. That means, doesn't it, the x is between negative 2 and 4, so we're talking 0, 1, 2, those values in there. That's just all that means. So it's everything between negative 2 and 4, in that case not including the endpoints. But okay, so here's where am I on these expressions for this one? X approaches negative 2 from the left. Well, that would be approaching negative 2 from the left, so that's the less than side of negative 2. So which one? X plus 1, yeah. So that would be using the x plus 1. So wouldn't that limit be negative 2 plus 1, which is negative 1? If I approach negative 2 from the right, that's the greater than side of negative 2. Well, that would include this one, wouldn't it? Because this one is everything from negative 2 to 4. You use this one. So that would be from this side of negative 2. So I would use x over 2, which x is negative 2. So going to negative 2, so I can substitute that in. Hey, look at that. It's also negative 1. So what can we say here about the limit as x approaches negative 2? Since both of these are the same, doesn't that mean then the limit x approaches negative 2 of f of x is negative 1? So in that case, they did agree, so you can say you do have a limit there.